Section 3.4 is the last section covering systems of equations, but in this section we're adding a third variable and a third equation. So here's what a problem would look like. You see we have three different variables, x, y, and z, and we have three equations. This is always how systems work. Previously, we had been working with two variables. We always had two equations. If we wanted to solve a system with four variables, which don't worry, we won't need to, but we would need four equations. Now for organization, let's label these equations, equation A, B, and C. And our goal here is to create two new equations with one of these variables eliminated. So if, for example, we could have only x's and z's in a new equation, two variables, two equations, and we can solve it like we did in the previous lessons. So we're going to use elimination. And first thing we want to do is pick which variable we want to eliminate. Okay, so now x would be a good one because we could turn this 2 into a 4 and we can turn it into a 6. All right, but instead of x, let's do the y. And the reason I'm picking y is because we have this y right here without a coefficient, or really an invisible 1 as a coefficient, and we can turn that into a 2 and 3. All right, so as our first step, we're going to use a and c to eliminate y. Now this is the key equation. We're going to use this equation 2 times because we can turn this y into matching or really opposite values of what we have up there. All right, so here we have a and c. We want to eliminate the y's. Okay, we want to make them match. So to do that, we're going to multiply this bottom one by 2. Okay, then we would have a 2 up here, negative 2 down there. Okay, so this equation on the bottom times 2 turns into 12x minus 2y plus 8z equals negative 2. Okay, top equation I haven't changed, I've just copied it over. Right, now we're doing what we did in the last section. We're just going to add these together so the y's cross out, and we're left with this equation. 16x plus 11z equals negative 1. Now we want to do the same thing again, and we're going to continue to use this key equation. All right, but this time, instead of using it with equation A, we're going to use it with equation B. So here are equation B and C, and we're going to continue this same process of taking this bottom equation and changing it so these y's match. So in this case, we want them both to be 3's. We want one positive and one negative. Let's make this multiplied by a negative 3, so that way we would end up with one positive, one negative y. Okay, so this goes to everything, and we end up with this guy on the bottom. Negative 18x plus 3y minus 12 equals positive 3. Top one hasn't changed. Okay, combine like terms, and we get this equation. Okay, negative 16x minus 7z equals negative 11. So let's take these two equations. I've labeled them with D and E. Okay, so this was the first one that we got, and this was the second one we got. All right, and now we have a two variable system with two equations, and we're just going to solve this like we did in the last section, section 3.1. So elimination's easiest. We can just add those together. We get 4z equals negative 12, z equals negative 3. Once we have this, we can take it and we can plug it in to either one of these. I'm going to say we'll plug it into this top one. So 16x plus 11 times negative 3 equals negative 1. That gives us 16x equals 32 once we add 33 to both sides. And we solve it for x equals 2. All right, so now going back to the beginning, we had these three equations, and we now know what x is and what z is. Okay, x was 2, z was negative 3. And we're just going to pick one of these equations and plug in the two things that we found. Doesn't matter which one we pick, all of them will give us the same answer for y. So we plug in that 2 for the x, negative 3 for the y. We have 8 plus 2y minus 9 equals 1. Solve it out, and we get y equals 1. Okay, when we write our answer, we write it as a 3 variable coordinate point, x, y, z. So 2, 1, negative 3. So as you can see, these are a lot of work, but it's a familiar process. It's really the same thing we've been doing. There's just a lot of places where we can miss a negative or add two numbers, mistakenly get a wrong answer, and it fouls up the whole rest of the problem. So just be careful when we do these. All right, let's do one more. So this is example 2. We'll label them A, B, C, and we want to pick which variable we want to eliminate. So in this case, we have really a few different options. We can eliminate the x's, the y's, or the z's. All right, let's go ahead and stick with the y's. Okay, so let's use A and B to eliminate y's. This is going to be our key equation here because this y has no coefficient. We can turn it into that 2 and that 4. All right, so let's make these y's match each other. We'll take the top equation and we'll multiply it by 2. So we do that. We get 6x plus 2y minus 4z equals 10. We're adding these together. Make sure you don't cross out the x's here because they're going to combine to 12. Y's cross out, and we end up with this first of our new equations, 12x minus 3z equals negative 8. Okay, we're going to use this key equation again, and this time we're going to use it with the third one because we already did that middle one. And again, we want to eliminate the y's, so we'll multiply this top one by 4, and we'll add a negative in there, so we'll multiply by a negative 4. Okay, that way it switches to opposite y's. All right, so we have negative 12x minus 4y plus 8z equals negative 40. Y's will cross out, and we have negative 11x plus 11z equals negative 33. So we have these two equations. It's not as easy as the last example where we had the x's already matching. So this is a more complicated elimination problem, but we just have to pick which one we want to eliminate. So let's say we want to get rid of these z's. Okay, so we'll multiply the top one by 11, bottom one by 3. We'll make them both into a 33z, and they're already opposites. Okay, so these are our two new equations. If we add these together, we get 99x equals 99, so x is 1. Okay, take that, plug it back in. We're plugging it into this top one here. So 12 times 1 minus 3z equals 18. Solve it out, and we get z equals negative 2. Lastly, we take the two answers that we just found, and we plug them into one of these equations to solve for y. Okay, let's pick the easiest one. So this has a y by itself. We plug in a 1 for the x, negative 2 for the z, evaluate it, solve it, and we get y equals 3. Always put your answer into that 3 variable coordinate point, x first, y in the middle, z at the end.